Hello children, good morning again. Let's continue with our sound chapter children. Yesterday we learned about the basic points about sound, like how sound is produced, what is sound, what are the major types of classification of waves, and under that we learned about two types of waves, one transverse waves and the second longitudinal waves. I told you that sound is a form of is an example of longitudinal waves. That means sound travels in the form of waves which comes under the type of longitudinal waves. So here, for example, when sound is produced by some source. Now what happens between the source of production of sound and your ear, like when you hear it, between your ear and the source of sound there is some medium, like for example it can be a solid medium, it can be a gaseous medium, or it can be a liquid medium, and how this energy of sound, it travels from the source to your ear. That is what we'll be learning today. Okay. Sound waves travel in the form of longitudinal waves. In my last video, I told you what are longitudinal waves. Here, the particles of the medium, that means if it is an air medium, then the particles of the air. If it is a solid medium, then the particles of that solid. Or if it is a liquid medium, the particles of that liquid. Those particles, they vibrate. They vibrate to and fro in a direction parallel to the propagation of wave. Here you can see the sound is produced here and the wave is moving in this direction and reaching your ear, right? So you can see that the wave is propagating in this direction, and how it's happening we'll learn now. So that disturbance is carried by the particles of medium. It doesn't mean that the particles are moving from one place to another. Okay. Be very specific and understand it clearly children, that only the energy moves from one place to the other and the particles simply vibrate. The particles of the medium simply vibrate, that's all. They don't move from one point to another. You can't say that the particle of air over here, they travel, they carry the sound and they just, they make it up to your ear. It's not like that. They are not carrying the sound waves up to your ear. Instead, only the energy moves here. So one very important thing what you have to remember, the particles vibrate in a direction parallel to the, say for example, if there is a spring, you know the spring, right? You take a big spring, I don't know what it's called, children play with it, big spring, and then you just push one end of the spring. You will see that the coils of the spring will come closer like this. First it comes closer like this. Rest of the springs, rest of the coils, the other coils will be free in their own place. And then once you push back, what happens? Some of the coils will relax. And again you push. What happens? That compressed area moves forward and a new region of compression happens. So again, when you repeat pushing and pulling, pushing and releasing, so you will see that disturbance, it moves throughout the length of the spring. So that is how a sound, you can just compare that with how the sound travels actually. So when a source of sound produces sound, so what happens now? It pushes the just immediately next to the particles which are present immediately next to the source of sound. So now these particles are under they are pushed by this energy. So they come closer. These are the particles. What I drew are nothing but the particles of air medium. So when the source of sound is producing sound, the sound energy, it just pushes the particles which are just next to the source. So then some particles, they come closer, and this particular region where the particles are vibrating now. How do they vibrate? I told you they vibrate to and fro, right children? So when they are pushed, they come closer, and this is called as compression. This region of the medium where the particles have come closer, it's called as compression. Now when they stop producing the sound, now they relax. Okay, they relax. How it happened in case of spring, in the same way it is also happening. When there is no sound that is produced, again the particles, they come back to their normal position. First to and then fro movement. Like this they vibrate, right children? So that disturbance, it moves on. You can sound wave, you will see regular, okay, intermediate compressions and these relaxed particles in the medium, that region of the air medium, they are called as rarefactions, children. So a sound wave has intermediate compressions and rarefactions, children. You can see after a rarefaction there is again a compression. Rarefaction, compression. Like that the wave moves in a forward direction. So these are the characteristic features of a longitudinal wave. We are learning sound waves here. Okay. So what are rarefactions? The relaxed particles. So when they are moving close by, they are forming compression region. When they are moving away, because they are vibrating to and fro, can you imagine, children? When they are coming closer, they are forming compressions, and when they are moving away, they are forming rarefactions. Okay, this is how the wave propagates and reaches your ear, children. Okay, we'll learn again how our ear senses the sound and how our brain actually analyzes or senses the kind of sound that you are hearing, and how it all happens. That's understood today's lesson. In case you didn't understand any point, you please ask me, and go through your textbook also. It's very nicely given in your textbook also how the sound waves reach your ear, how the sound waves propagate through different media. Okay, children? So this is about sound today for today's class. In my next class, I'll be teaching you about the properties of sound waves. Like what are the different things which we can learn about the sound waves, children. Okay, thank you.